Welcome to our talk on Entity Framework Core. My name is Diego Vega, and I work as a program manager on the Entity Framework team, obviously, and I also own, as a program manager, data access on .NET. And this is Andrew.
Hi everyone, my name is Andrew Peters and I'm an engineer on the EF team, and I'm super excited to be here today to demo some of the cool stuff we've been working on in 2.1.
All right, so before we actually go talk about all the new features and demo the new features, we wanted to give you some context, especially when we started. Actually, before we wrote the first line of code for Entity Framework Core, we met and we had this discussion about what the guiding principles were going to be for us and what we wanted Entity Framework Core to be. And we wanted it to be rich in features, but also simple. And by that, I mean simpler than other offerings, simpler than even our own Entity Framework. We wanted it to be lightweight because many other object database mappers use a lot of memory, and they were not very well aligned to the needs of cloud computing and mobile computing. We wanted it to be extensible so that you can apply your imagination and come up with new scenarios that we couldn't think of. We wanted it to be cross-platform. It was one of the main themes of .NET Core. And we wanted it to be good for relational databases because that's what many of our customers were using, but also potentially good for non-relational databases as well. And we wanted to have a common set of abstractions that you can use across all those different kinds of stores, but without getting in the way whenever you need to actually leverage the store that you decided to use for your application. If you want to use a feature that is unique to your store, then EF Core should not get in the way. We use this principle that we call pay-per-play, which means that you should not pay for the cost of some complex feature if you're not using it. And something that helped us also define what we wanted Entity Framework Core to be is that we didn't want it to be like EF6 in many ways, that you can call it a reaction because we had been working with EF6 for many years and we knew what customers thought about it and we knew what we thought about it. Entity Framework 6 is very complex, especially from the perspective of all the mappings that it can support and the way the mapping works. That made it very difficult for us to add features to it. It also made it use a lot of memory and made it have a very slow warm-up time, that would take a long time to create the model. And we wanted to add features to EF Core based on the merit of those features and not because they were features in EF6, although we understand that we get a lot of feedback now that many customers say, hey, I cannot use EF Core because there is this feature that I have been using on EF6 that I use it a lot and it's not there. We also, as a consequence, we thought, well, the move to EF Core is not going to be just an upgrade, it's going to be a port, actually. Those are two different products. So that context, I'm giving it just because I want to explain how these new features play a role into that vision. So lazy loading, for instance, is a feature that EF6 had that in the beginning we didn't build it because it was very dangerous, it was controversial, and we didn't think it was critical. We accept that for many people it's important to have lazy loading. We're going to demo that and we're going to explain some of the pitfalls. Data seeding, this ability to populate a database with data before you start using it. Query types, we're going to demo those, so I'm not going to explain a lot. Value conversions is a very cool feature that we are going to demo today. Constructors that take parameters for your entities is a new feature. And we do group by translations, which is something that EF6 did very well. In EF Core it's slightly different. We generate some richer SQL with having statements or clauses, but it's more focused on doing aggregates than anything else. We have a new analyzer to detect some situations in which you can run into the possibility of SQL injection. We have many other smaller features that we work on, and some work that we have been doing when we were working on 2.1, but it's not actually features for 2.1, like the Cosmos DB provider that we have at the prototype level right now. Oracle provider, and some improvements for UWP. So let's start with the demo.
Okay, thanks, Diego. So the first demo we want to show you guys today is data seeding. So here I have a simple blog and theme model. So this is clearly a very sophisticated blogging engine. We have a blogging context. We have normal blogs and theme sets. And what we'd like to do is when we deploy our blogging engine, we'd like to have some themes already defined, some themes set up. So if I run this now, we should see we don't have any themes created yet. So in EF Core 2.1, we have a new API. I'm going to drag on a little bit of code first. So the new API has data, and it sits off the entity configuration in code first. And what it allows me to do is to pass in some of my POCOs, my entities, newed up, representing data that I would like to get registered into the EF model. And so this is the first time we've had data in the EF model like this, and it gives us a lot of advantages. The first one that we're leveraging is the ability to manage the data in migrations.
Yeah, if you compare this to how it worked in EF6 it was an imperative model. Data seeding was just a method on the migrations configuration that we execute every time. This one, actually, you can version the data together with the schema of the database.
Yeah, so I'm going to drop out to .NET EF tool here and generate a migration for this. So I'm adding a new migration called seed data. Okay, that's done. Let's open it. So you can see here we've scaffolded a new migration, and we have some new APIs in here corresponding to insert, update, and delete. So we're inserting this data here as part of this migration. And naturally, we have the down method implemented. So we haven't unified these delete data yet. We need an API that takes multiple data rows, and we're thinking about doing that. So now we can apply that. So I'm going to run the migration. So what this is doing is just taking that migration we just generated and running it directly against our database. Now if I run again, we have our seed data added. So this is quite nice. Now what we can do is, let's say we would like to change one of the data values. We're going to go and change this one to Alice Blue, because we like that one.
I like that color a lot. How many of you know how Alice Blue looks like? Wow. One person, two people.
Got some people. Let's scaffold another migration. Okay. So here we've just detected that there's been a simple data change in the seed data, and we're scaffolding a corresponding update to take the value to the new value. Let's show that one. We can, instead of running it this time, let's just script it out. So obviously with migrations, you have the capability of making the changes directly into the database or scripting them out. Is that migrations? Yeah, sorry, my bad. Okay, so that just scripted out the changes for us. We can give that script to a DBA, and we can see here we have the update statement scaffolded out there.
Yeah, one thing you can notice at the end of the previous migration in that script is we are setting identity on SQL Server, because the actual numbers that you put on the key properties of your entities, we are actually using them on the database. We need to insert them with that option if they are identity columns.
Great, okay. So that was seed data. Now let's take a look at value converters. So I'm going to switch over. Let's close that, set this. So here we're using the same model again. And what we realize now is that we'd like to actually, instead of storing the string name of the theme color in the database, we actually would prefer to just use the color object from .NET. So you can see here when we added the seed data, we were using the color type, but we're actually at the moment just essentially serializing the name of the color into a string column. It would be much nicer if we could just use the color directly. So let's make that change. So this is what value conversions allow. So we're going to teach EF Core about a new value type that it doesn't know how to map yet. You can also see here, we're using ushort. Diego can talk about that.
Yeah, ushort, maybe you are not aware of this, but SQL Client, that is the provider that we are using right now, and SQL Server is the database, they don't support unsigned integers. So in previous versions of EF Core, if you try to use a property of that type, it would throw saying, I don't know how to map this to SQL Server. With value converters, automatically we have some like 80 built-in value converters that are going to be selected automatically for an unsigned integer, unsigned short in this case. It will pick up the next signed integer type that can actually hold all the values for ushort.
Yeah, so as Diego said, we have a bunch of these built in. Now let's try and run this. Okay, we made the change to color. We had to update the seed data call because obviously our POCO now takes color. It should just work. Oh, boom.
Why did it fail?
Okay, what did it do?
So I think that EF Core and the SQL Server provider, they have no idea how to deal with the color type.
Okay, so this is kind of expected. We generated a good exception just telling you that the property theme title color could not be mapped because it is of type color, which we don't understand yet. So what we need to do is just add a little bit of code first to teach EF how to map it. So, Model Builder, the theme entity for the title color property, has a conversion. This conversion, we're giving it as 2 lambdas, and these lambdas are how we're going to teach EF to send it to the database and read it back. The first one says, when I'm given a color, I'm going to send its name into the column. And the second one says, when I read that name, I can use this API to turn it back into a color.
There are several overloads of hash conversion. There are some that just say, this is the store type, this is the database type, and we can pick automatically one that we know. For instance, an example of that is you have an enum property and you want to store it as a string. We automatically detect, okay, the way to do that is to call toString and then parse on the way back.
Yeah, so awesome. Thank you. So I think you can see how this is really powerful. So especially for databases that might not have a certain type that you want to use. Oracle doesn't have a GUID type, for example. And so you can just choose different strategies for how you want to map that. And you can see here, so now we're getting a different string representation. When we print out the property, we actually get the color2 string instead, because before we were just printing out the name.
For .NET Core 8.0, we are going to print this in color, actually.
All right, so that was cool. Let's talk a little bit about something that's debatably cool, lazy loading.
Yeah. How many of you guys look at the SQL that your ORM, your favorite ORM, doesn't need to EF generates before you deploy the application to production? Can you raise your hand? Okay, so everybody else, please close your eyes. We're going to distribute earplugs so that you don't see this demo. Actually, we dedicate this feature to people that are going to use it responsibly because it's a dangerous feature.
Yeah, okay, so here we have a blogging context again, and our little program is just looping through the blogs and then looking for posts. If there are any posts, it's going to print them out. If there are no posts, we're going to write no posts. So right now, we don't have any lazy loading enabled. We're not using include on this query. So include is the eager loading mechanism you can use to say, I want the posts. I always want the posts. So what we should see now is we get no posts. Okay. Let's enable the first pattern that we support of lazy loading. So that's using proxies. So we use the Castle proxy package, and what this will do is generate at runtime subclasses of your entities that will do interception for lazy loading. One important thing to note here is that we don't enable this by default. So lazy loading is never enabled by default. Okay, so we have a one-liner in our startup or in our on configuring, which says use lazy loading proxies. Let's run it. It should just work perfectly. Oh.
What happened again?
Okay.
So, okay. I think I know why this happened. The type log is not the property is not virtual. Okay, so in EF6, this was like a super common mistake that people made. You can enable lazy loading, but then if you don't make the property virtual and we have to create a proxy, we have no way to override the getter for that property, and therefore we cannot enable lazy loading. So in EF Core, we have made it by default much more strict. And the idea is that, well, if we get enough feedback, we're going to give you some control. You can think that in the future you will have the ability to tell us, okay, for this property in particular, I don't care about lazy loading. But this is with the goal that you don't make that common mistake anymore.
Yeah, so you have to be explicit. Okay, so we made the property virtual and we got the post loaded. So that's great. So apart from adding the proxying pattern, we also added a more lightweight way of enabling lazy loading. It involves adding a little bit more boilerplate code to your entities, but it means now you don't have a dependency on an external proxying package. And it's just a little more lightweight that involves a little more code. And we're going to show how we can still do this in a pretty POCO way, so persistent ignorant. So I'm going to disable this. So no more lazy loading with proxies. Let's bring in this snippet. We can talk about this. I'm going to delete this guy. All right, so we've added a private constructor. It's taking this special action. So this is a special delegate that EF will give to this constructor when it creates an instance of the blog. And then what we're doing is we're stashing that away in a field, lazy loader, and we're using that field to call back into EF, essentially opaquely, in the getter for the navprop. And inside this delegate, what it will do is actually cause a load of the navigation property. So we're in no way dependent on any EF-specific interface here. We're just dependent on action. So this blog entity doesn't need a direct coupling to entity framework, but it still allows us to do lazy loading in this way.
This is the version of lazy loading that is for people that like to drive manual transmission cars. It's also the right version of lazy loading if you are targeting something like Xamarin or UWP, that things need to be compiled ahead of time, and you cannot at runtime generate new types with like proxies.
Exactly, and so obviously now I should be able to do sealed, right? No more subclassing. Okay, so it still works the same way. Now we're just going to quickly look at the SQL that gets generated for this so we can understand some of the potential issues. I'm going to just enable logging. So that just involves bringing that guy in, some little bit of config. Okay, so I've set up a logger here. Let's run it again. Okay, here, so we should see 4 queries here. So this one is for all the blogs, and then on each axis of the navigation, we're seeing the classic n+1 problem. So there's one there, and one there, and one there. So we get 4 total queries. If we had have used eager loading with include, we would have 2 queries only, and it would always be 2. So this lazy loading one will scale with the number of blogs that we're actually printing out.
And this is why we say that lazy loading is a dangerous feature. Obviously, if you have only 4 rows in the table, it doesn't matter. But if you have 1,000, then it matters. And you should always profile the SQL that the application is generating.
Yeah, and one thing we've been talking about is internally we can probably detect some of these cases. And already in EF Core, we have a warning system that will generate warnings for these types of things. So if we can detect some of these n+1s, we could generate a warning. Our warning system lets you turn our warnings into errors at runtime. So you could essentially make this throw, which could help you to find these kind of issues.
Right.
Oh, great. So let's talk about query types. I'm going to switch to that one. So what are query types? Diego, do you want to give an explanation?
So query types are types that you declare in the EF Core model. They are like entity types, but they don't have primary keys. And because they don't have primary keys, we don't track them for changes, so we cannot save them back to the database. But they are very useful for scenarios in which you just need to query some data from the database, like you have a view in the database that you want to map to an object, or you have SQL statement that you want to execute, and it has the result has a shape that doesn't match any entity, so you can include this type in the model.
Yeah, exactly. So what we have here is a simple store model. We have a customer, products, and orders. We're adding some customers, some products, and some orders. And then here we're just dropping down to one of our low-level SQL APIs, and what we're doing is just creating a view. So this is very common. We have a view on the database that's aggregating some stuff together, bringing in just some data, maybe for a report. There's no natural key for this view. We don't really want to create an entity type. We're never going to want to save changes on it, but we actually want to be able to query it and also leverage the full mapping engine that we have for entities. So I could want to map which columns it goes to, what the name of the view is. I could want to have navigations that come out of this type. I could want to use inheritance. So we don't want to throw away all of the mapping capabilities that we have just because we don't have a primary key. And that's really what query types solve.
You can also use value conversions on the properties on this type, by the way.
Yeah, exactly. So it's just like an entity type, but it doesn't have a primary key, and we treat it slightly differently. It's never tracked. So if I have this view, that means I probably want to create a type that represents the results. So this is the thing I'm going to register in code first. The way I'm going to do that this time is by using a DB query. So this is just the analog of a DB set. It's just a little more limited in its API. It doesn't have any of the update methods on it. But as soon as I do this, EF will be aware of this type, and it will incorporate it into the metadata model. And now we've got that, we should just be able to query it in the same way we would normally. Okay, great. So we're able to query our view and take advantage of the full mapping capabilities. Thanks.
Thank you.
Some other points on that. So it can map to a table, can map to a stored procedure.
You can map to a view or a
view.
Defining query. You want to talk about defining queries?
You can talk about that, and I'll bring in this bit.
Sometimes instead of creating a view on the database, you may want to create something that is like a view in the model itself, in the EF model itself. So we have a toQuery method that you can use when you are mapping this query type. Yeah, and inside that toQuery method, you can use a link that refers to another entity, or you can use from SQL as well.
Yeah, and another pattern we have, which is this one. So I might just want to create that shape and provide the SQL in line. So I don't have the view, but I just want to put it in line. So we have this cool from SQL operator, which allows for you to drop down to SQL for your queries and even compose over it after that with more link operators. And so this is kind of a natural way to write a query and just get results. So now we'll be using that SQL instead of the underlying view.
Yeah. We had I'm glad you like it.
Right. Let's talk about the analyzer. Do you want to describe the problem, Diego?
Sure. In EF Core 2.0, we introduced a very cool overload of from query and execute SQL command that takes an interpolated string from C#. It's very cool, really, because it gives you a very concise way of expressing a parameterized query. You can write just a $sign before the string, put your placeholders there, and we will actually parse that interpolated string and replace the placeholders with parameters, and everything is good. The problem is the way interpolated strings work in C# and in .NET in general is that as soon as you refactor this code to put this select statement outside the call to execute SQL command, let's say that you put it in a var, the compiler will automatically generate the code to produce a string instead of an interpolated string. So there is a type that represents an interpolated string that is called formatable string. But as soon as you do var a or var SQL equals, and you put this $sign thing inside, it's not one of those anymore. It's just a string. And at that point, everything is just concatenated. It has stitched together the value of the parameter instead of giving us the opportunity to create the parameter. So it was kind of a mistake to do the feature in that way. And in order to mitigate the problem, we decided to create an analyzer that can detect all the possible misuses of this API. In the future, we are considering actually separating the overload that takes the interpolated string from the one that takes a normal string so that there is no ambiguity of which one you are calling. But for now, we have this analyzer.
Yeah, and it was kind of somewhat of a happy accident because we've been meaning to try and look into analyzers for a while. We feel there's a lot of places in EF where we could add value to just helping you to use EF in the way we've kind of intended. So there's various mistakes you can make, or not anti-patterns, but just places where you could write code a different way and be more idiomatic with EF. A good example of this is in on-model creating. We see a lot of people doing like redundant configuration. So EF Code First has conventions that will work out table names and column names based on the CLR types. And some customers will actually just reconfigure those to be all of the same values we would have worked out with the convention. And so that would be a great place for an analyzer to say, hey, you don't really need this line of configuration here because this is just the convention. EF will use this value anyway. So you can see in this case, we just have detected that this is actually a potential SQL injection vulnerability because you're using one of our APIs, but it's actually, you're creating an interpolated string here because we did a refactoring. We pulled this out into a local, and it's a potential string concatenation, like injection vulnerability. There's no way EF can parameterize this because we've lost the ability to separate the format string from the separate values that you get when you actually inline it.
Right. So let's go back to the slides. So what's next? We wanted to talk a little bit more about what we are working on now that we plan to release for the next release or the next 2 releases. So we are actually doing the planning right now. This week we are going to complete some of the planning for EF Core 2.2 and 3.0. These releases are going to be aligned with the dates of the .NET Core 2.2 and 3.0. And as you can see, we have 2 columns, decided and undecided. The decided column is that we are doing the Cosmos DB provider. We are finishing it in the second half of this year. And undecided is basically everything else that we hear from customers that is really important to them. We know that we are going to do some of this, but we haven't decided which ones. Spatial is super important, and it's going to continue to be important, and it's kind of blocked in EF Core, and we need to do something, really. Store procedure mapping refers to the ability to have insert updates and deletes mapped to store procedures in the model. And many-to-many refers to the fact that you can have 2 collections pointing to each other without having an entity in the middle with additional data, for instance. TPT inheritance, people that know that they want TPT inheritance know what TPT is, but it's base table and then separate tables for each derived type in the inheritance hierarchy. JSON column mapping is another interesting thing that we get a lot of feedback on. Many people apparently want it. And with type converters, actually, we enable part of it. You can already serialize any object to a JSON payload and store it in a column as a JSON payload if you want. But we want to do something richer than that. Property bug entities are entities that are not strongly typed. It's basically you can have something like a dictionary that contains the property values. And there are some low-hanging fruit like reverse engineering to views. Now that we have query types, we can take views on an existing database and generate DB query properties to enable that. Better support for Xamarin. Right now, in Xamarin, you need to annotate some types because otherwise the Xamarin linker is going to remove them from the output, from the native output. So we are thinking about like exploring what things need to be preserved and just adding the annotations in the product. Let's demo one of these things that we are working on.
Okay, cool. Yeah, so we have been working on the prototype for the Cosmos provider. It's super exciting because when we did EF Core, we actually wanted to do NoSQL. We had it in mind, so we put a lot of like architectural things in early on that we haven't really been able to leverage until now. Specifically in like the link translator, we did some work to make it easier for NoSQL stores to kind of expose link. So I'm just running the DB emulator here. I'm going to refresh on this just so you know there's like nothing funny going on.
Nothing here, nothing here.
There's no database in here yet. Okay, so that's empty, right? Oops, don't drag it. Okay, so we have a simple program that's just going to use some of the very top-level, simple EF APIs to work with Cosmos. So we have a blogging context again. Here we're just recreating the database using the standard APIs in EF Core. Delete it, create it. Then we're going to add some data to some DB sets. And then we're going to read it back and make some changes and save it. Let's take a look at our context. We can see here the main difference is that in our on-configuring, instead of use SQL Server or use Postgres, it says use DocumentDB. Now this name is going to change probably, but this is just bringing in our Cosmos provider. And obviously its arguments are the Cosmos-specific connection information that we need. And in this case, it's to the local emulator. And we've also enabled logging like we saw before, so we can kind of see what's going on. Let's run it. Ooh. Okay, so this is an unexpected error. Great.
Yeah.
Not a pre-canned one.
I'm sure I cannot tell you why that failed.
Yeah, Diego, why did that not?
Now it's a real demo.
Yeah, now let's try reboot the emulator, I guess. It looked kind of like what the error was.
It only fails when it's important, you know, when you are showing it. Usually it works very well.
Yeah, I used to think highly of this emulator. All right, come on, baby.
You didn't say baby, right? You say body.
Yeah. Did it start up? Nope. Wait, does someone know what the process name is?
More details.
More details.
One that is using a lot of memory, maybe?
It's Visual Studio?
No, not that one.
Yeah, I have no idea what it's called. Yeah, the old reboot. Well, I guess we can try again, otherwise.
Somebody search what the process name is, please. Use Bing and use Edge to search for it, please.
Do you want to switch to the slides?
Sure.
And I'll try
Okay.
and do what was suggested.
Okay, I'm going to move my hands now. So we want to talk about this other thing that is called NT Framework 6. It's not in the title of the talk, it's a surprise. So we are porting NT Framework 6 to .NET Core. We announced this on Monday, so probably it's not a surprise for everybody here. This doesn't change what we advise people to do. We advise people to use NT Framework Core if they are creating a new application. We also advise people to port to EF Core if they can afford it. By that, I mean if NT Framework Core has all the features already that you need, or maybe if version 3 of NT Framework Core has all the features that you need. And also if you have the ability to invest the necessary time to do the porting. But we wanted to smooth the path for everybody that is using EF6 today, that is heavily using features from EF6, and they want to move to .NET Core and to ASP.NET Core without paying the cost of a full port exercise. We are not investing on new features for EF6. However, it's an open source project. We are taking pull requests. We are being super slow at the moment taking those pull requests, but we promise that for EF6.3, we are going to process all the pull requests that we get. Worst case scenario, we are going to reject some of them, but not because we don't have the time, hopefully. There are going to be limitations when we do the porting. For instance, SQL Server spatial support on EF6 depends on a library that SQL Server provides that is SQL Server version specific and is for Windows only at the moment. Unless they port it to .NET Core as well, then this is not going to be available. Also, if you are using a database provider that doesn't come from Microsoft, it's not one of the ones that we produce as part of the Entity Framework project, then those guys are also going to have to port to .NET Core in order for the provider to work. It's going to be relatively cheap. If we did, the other day we actually did one of these API porting analysis on the code base, and we found like 95% of the APIs that Entity Framework 6 uses are already available on .NET Core, and 99% of the APIs that the SQL Server provider uses are available. There is actually one API that is not available on .NET Core for the SQL Server provider. And there has been a little bit of confusion because of some diagrams that we showed. Just to clarify, EF6 is going to be cross-platform, and it's going to be for desktop, but also for web applications. It's probably not going to work on Xamarin, and it's probably not going to work on UWP because it uses things that are not available there, but we don't know yet for sure. And also, we have tooling for EF6. We have the designer, and we also have migrations command line tools that you can type, like the PowerShell commands that you type in the package manager console. Those are the latter are going to need some re-architecturing to work if your project targets .NET Core. And the designer, we believe that we can make it work just running everything on the normal EF6. No, it's not normal, sorry, the .NET Framework version of EF6. But there may be limitations. Worst case scenario, we're going to require that you put the EF6 model and the migrations in a library that can be consumed from both .NET Framework and .NET Core.
I got it.
You got it?
Yeah.
Awesome.
It needs Wi-Fi, even though it's not using Wi-Fi. Okay, so I ran it. We can see here, we created the database. We saved some records. Now this is interesting. This is actually SQL for the Cosmos DB SQL APIs. So they have their own flavor of SQL. So we're generating that. Let's jump over here. Here's our sample app. You can see right now we're creating two collections. We're still talking about, obviously, what are the good ways to map from an EF model into a Cosmos data store. But what we hope is that we'll be able to provide code-first configuration options that allow you to map in different ways depending on what makes the most sense for your application.
Yeah, we hear that for the default pricing model for Cosmos DB, it actually makes sense to map everything to a single collection by default. And we are going to support it.
Yeah, so we can look in here. We should be able to see the JSON representing how we kind of shredded the entities down. These are the properties, primary key, and we even have a discriminator here because in our example model, we were using inheritance. So we should see number 4 is a special blog, and then we have the posts. So we're super excited about continuing to work on this and make this like a really nice experience for using Cosmos with the kind of knowledge and APIs that you already know and understand.
Awesome. So this is a small diagram with a little bit of information about the features that exist in EF Core today, the features that only exist in EF6, and what they have in common. I'm not going to read all of this, obviously. But when you download the slides, you can take a look, or you can take pictures now if you want. We found in the booth people that came to talk about EF Core and EF6 found this very useful. So one more surprise. So part of the work that we do is not just for EF. We do a lot of work for ADA.NET as well. And we have been working with people from the community, like Shai Rojansky and Bradley Granger. Those guys write the NPG SQL provider. That is the provider for Postgres. And Bradley works on the MySQL connector. That is a provider for MySQL. It's an open source provider for MySQL. It's not the only one. And we have been working on trying to make .NET Core really shine on database access benchmarks and just make it faster, not only for the benchmark, but for everyday use. And these are preliminary results from a run that is happening right now. If you go to Tech Empower and you look at their continuous integration kind of dashboard that they have, this run hasn't finished, but we are seeing the results of ASP.NET Core because they are alphabetically ordered at the top, so they run first. And we saw this nice surprises with all the work that we have been doing on .NET Core performance, on ADO.NET Core performance. These tests are completely beyond our expectations. The results are so great that we believe that with these results, ASP.NET Core becomes the #1 mainstream framework for web applications in performance for data access. I want to thank people from the .NET Core team, Andrew, that worked very closely with the guys from the community. I want to thank Shai and Bradley for these improvements. And I want to thank everybody that has been giving us feedback and giving us code contributions as well. And I want to thank you for coming here today. And this is the slide for the feedback that contains a nice phone there. Please give us feedback on our presentation so that we can do it better next year, hopefully. And thank you for staying late at Build. I hope you had a great time this year. And the last guy, please turn off the lights and close the door.
Thank you.